This video will cover section 1.2 graphs of equations, and it is for the class Math 13-14. The objectives are listed here on this slide. So we have sketching graphs of equations, identifying x and y intercepts of graphs of equations, and then use symmetry to sketch graphs of those equations, and also to write equations of and sketch graphs of circles. And we will be using the distance formula to derive the equation of a circle. And lastly, we will be using graphs of equations in solving real-life problems. So we discussed in the previous section how we are going to work with the rectangular coordinate plane or the Cartesian plane. So when we graph equations, and you might be thinking, why not functions? Well, we will get to functions within the next lesson, or maybe two. So right now we're just going to call them equations. But yeah, some of those equations could be functions. And so the graphical picture is a collection of points that satisfies the equation. So for example, since we have here the equation y is equal to negative 3x, that is what we call an equation. And so any point that is on that graph is going to be in the form of xy, or in this case we're calling it a comma b, just to represent a number. And so if we were to substitute those two numbers, for example, we will substitute a here, or no, here in place of the x, and then we will substitute b in place of the y. So then we will get a true statement. So that is what we mean about being a solution. So we're going to have not only one, well, sometimes we may have only one point, other times we're going to have several points. And once you put all those points together, they start forming lines. This could be straight lines, or they could be curvy lines. So yeah, we will be studying some of those throughout the mini-semester. So every point that satisfies the equation could be called a solution or a solution point. And here we're just using the letters A and B to generalize that it could be any number. So x is equal to A, y is equal to B, and it results in a true statement. That's how we know that that point is in fact a solution. So for example, we're going to use a point that we already know is a solution, and the point is 1, 4. So we're saying that in x equals 1 and y is equal to 4. So if we take the equation that you see here and we substitute y with a 4 and the x value with a 1, let's see what we get. And you could see the substitution is already here. So let's just finish solving it here. So it will be 4 is equal to 7. First we need to multiply here. So negative 3 times 1 is negative 3. And we are checking if the left side is equal to the right side. And so if we subtract 7 or 3 from 7, we will get a true statement. So 7 minus 3, 4. So because this is a true statement, what that means is that the point is a solution, and therefore that point is going to be on the graph. And the collection of all those points is what in fact gives you the graph of the equation. So some of the techniques that we will be using in this class will be not only graphing calculators, we also need to learn how to graph things by hand. So we refer to that as sketching the graph. On WebAssign, you will get a chance to use technology. Sometimes graphing could get a little tricky at the beginning, so if you do have a question, make sure you use the tutoring, online tutoring, and ask for help. Don't hesitate to ask for help, or you could send me a message, but to be honest, I am not very familiar with the graphing on WebAssign, and so maybe a tutor could be of better help. So what we're going to do right now is the point plotting method to graph an equation. And so if possible, we're going to follow the steps that are listed here, 1 through 4. So if possible, we're going to isolate one of the variables. So that means to leave one variable by itself. Typically, we will be solving for y. So y equals, and then the rest of the expression. Now, why do we call it equation? I forgot to mention that. So we do refer to it as an equation because it has the equal sign. So after isolating one of the variables, if possible, we're going to construct a table of values, and we will do that on the next slide. So with that table of values, we're going to get some solution points, and those solution points are going to be plotted every single order pair. Remember, points are in the form x comma y. So we will plot them in the rectangular coordinate system, and then we will, if needed, we will connect the points. And I say needed because some functions or equations, well, yes, might not be connected. We refer to those as discrete. So the ones that we will be dealing with the most will be continuous, so they will be connected. But you might encounter a graph that is just made out of points that are not connected by a line or a smooth curve. So we connect the points, and that's how we graph something. So we're going to get a chance to do that on the next slide. Let's just mention that when we construct a table of values, it's useful to use negative values, to use 0, and also to use positive values. That way we can get a better example of what's going on both sides of the y-axis. So in this case, we have the solution here, but we are gonna I'm going to show you how you will do it if you were to be asked to do that for a quiz or a test question without using your calculator. So as you can see here, we have some positive values, and we have one negative value, and we have 0. So what I want to do is, let's just choose those numbers. So we have, pretend we don't have the table that is fully done here. So we have x, we have y, and we're going to copy the expression. You could see here that the equation is already solved for y, or we could say that y is isolated. So we have negative 3x plus 7, and then from here we're actually going to get the order pairs, x comma y. So we start with an assigned value of negative 1. So if we were to substitute the negative 1 into the equation here, and we will be substituting the x values right here in every place where we have an x. So I'm going to put it inside parentheses, and this will give me a value of negative 3 times 1 is positive 3 plus 7, and that is going to be equal to 10. So I'm actually going to make more space here. Okay, so 3 plus 7, that will be 10. And you can see here it is okay. So our order pair will be -1, 10. Okay, so for the next x value, we have here a 0. And I want to point out that these are not the only x values that a linear function could take. In fact, the linear function could take any value, any real number. So, but we will learn that in the following section. So now I'm going to substitute -3 times 0 plus 7, and that will be 0 plus 7, so that will be equal to 7, and this will be 0, 7. You can see the point is there. Next x value, I'm just going by the table here, but I could choose any single value that I want. Let's go with a 1, and that will be y is equal to -3 times 1 plus 7. So this will be equal to -3 plus 7, which is equal to +4. So the point will be 1, 4. Next number is a 2, so x is equal to 2. So now I'm going to substitute into the equation the 2 in place of the x, and then add 7. So this will be -6 plus 7, and that will give me 1. So the order pair will come from 2 for x and then 1 for y. And we could verify it here. Next x value, just going by this table, we have a 3, and we could use substitution. So -3 times 3. So as you see, I just keep substituting those values into the x. So we still need to add 7 because that is the equation. So this will be -9 plus 7, and that will give me -2. So the order pair will be 3, -2. The next x value we have here will be a -4. So y will be equal to -3 times, I said -4, but it should be +4, and plus 7. So this will be equal to -12 plus 7, which is equal to -5. So now that we have all of the x numbers here, we have all of our y numbers or y values here, we can make order pairs. So as you notice, for each x, and there is only one unique y. Only one y. And so because of that, I'm going to go ahead and tell you that this is a linear function. Not only an equation, but it is a function. But like I said, we will discuss what makes an equation be a function in the next section, I think, or soon. So we could see all the points. Now you can see the points are being graphed here already. And we did practice how to plot some points. So you can notice how every single point that we have represented here, that we also verified here, it's going to be here. So -1, 10, 0, 7, 1, 4, 2, 1, -3, 2, and then we also have here 4, -5. So that point is going to be here. Now we're going to spend some time working with linear functions, but not only in this class. I want to remind you that linear functions are going to be part of pre-calc 2, and if you have to go into calculus, they will be there as well. So just a quick reminder, we call this form the slope-intercept form because this is the slope, the -3, and this is the y-intercept, the 7. And also, we call it a y-intercept because it is a point on the y-axis, as you could see there. So 0, 7. And for all y-intercepts, the x value is equal to 0 by default. And so imagine any point that you will have on the y-axis. Let's pretend that's 5 for a y. The coordinates of the point will be 0 for x and then +5 for y. So every y-intercept it's going to have a coordinate of 0 for the x. And remember, the -3 is called the slope, but we will discuss this in the following sections. So we do have y-intercepts, but also x-intercepts. So for any y-intercepts, those are going to be located, well, let's organize the information. So y-intercept or intercepts are going to be on the y-axis, and also the x coordinate is 0. And when we talk about the x-intercepts, intercept or intercepts in plural, those are going to be on the x-axis, and the y-coordinate will always be 0. Okay, so based on the graphs that we have here, we're going to identify the x and the y-intercepts. So the first graph that we see, you can see clearly that it's not touching the x-axis, so it has no x-intercepts. Now, it does touch the y-axis here at this particular point, only one point, so it has one y-intercept. Now, the next graph, it does have 3 x-intercepts. I'm going to highlight them. And we see that that x-intercept in the middle, it does happen to be at the origin. So the origin, which has the coordinates of 0, 0, is going to be also considered the y-intercept. So we can see that also at that point, at the origin. And only one of those points is touching the y-axis. So next graph, it does have one x-intercept, that will be here, and it does have 2 y-intercepts. Now the next graph, which happens to be a circle, is not touching the x or the y-axis, so it's okay, we could just say no intercepts. So just like you can have no intercepts at all, you can have no x-intercepts or no y-intercepts, but have the other kind. So again, in summary, every x-intercept is going to be written as an order pair in this form. The y value will be equal to 0. And for every y-intercept, is going to be written as an order pair as well, that in this case the x is going to be equal to 0. Some textbooks will use the x-intercept instead of writing it as a point like we saw on the previous slide. So the x-intercept as a point, instead of that, they may write it as just using the x coordinate of that point. So it could say something like the x-intercept equals, in this case, a, because that's the letter we have here. Or it could be something like maybe a comma and then x equals a. So with WebAssign, be careful if you have to enter the whole equation like x equals to the number, or if you have to give your answer as a point, or they might have already the x equals and it's just like an empty box for you to enter the number. So please be careful with your notation. Now for the y-intercept, same case. Some textbooks, instead of using the whole point, 0, comma b, instead of using that, they just use the y coordinate. So in this case, it will be something like the y-intercept is going to be y equals, and I'm going to use the letter b because that's the example we have here. But remember, b and a are representing numbers. So how are we going to find those? Sometimes we will be given the x and y intercept and we will be asked to do things with them, such as finding the equation or graphing something. But sometimes we will have to find the x and the y intercept. So because of that relationship that we discussed, that for x-intercept, for all x-intercepts, the y coordinate is 0. That is exactly what we will do. We will let y be 0, and then we will solve the equation for x. Now, when we need to find the y-intercept, then we will let x equal to 0. Then we will solve the equation for y. And this is going to be true for all functions, and or just going back to equations, for all equations that we need to graph, so, or find the x and y intercepts. You will let the other letter, so for x-intercept, we let the other letter, which is y, be 0, and then we solve for x. For y-intercepts, we let the other letter, which is x, equal 0, and then we solve for y. And how do we let y equal 0? Well, we will substitute the variable with the number 0. Or in the case of the y-intercept, we will substitute the x variable with the number 0. So let's go ahead and practice how to find the x-intercepts. And we are given the equation here. And I will tell you right now, this is also a function. It is a cubic function or a polynomial of degree 3. We're going to study this in chapter 2. So the question is, find the x-intercepts of the graph. And so we're going to start with step number 1. We're going to let y equal 0. And so for that, we're going to substitute into the given equation, which is here. So it is y equals x to the 3rd power minus 4x. So we're going to make the y equal to 0. So I'm going to just replace that letter with the number 0. And here, since we have one side equaling 0, I am going to factor, so that will be my 3rd step. to factor. And if you forgot how to factor, it's fine. There are several ways that you can help yourself. You could Google how to factor, and but I will be going over certain things. In fact, in chapter 2, we will practice more about that. So what we're doing is looking factor between those two terms. And I say two terms because x cubed is one term, 4x is another term. How do I know they're two separated terms? Because there is a negative sign in between. So terms are separated by positive or negative signs. So in this case, if I look at the two terms, the one they do have in common is x to the first power, which is the one here. So that is what I'm going to factor out of that side of the equation. And when I factor, it's similar to dividing. So if I have x to the third power and I factor out x by the rules with exponents, when you divide two letters, you subtract the exponent. So we will be getting x to the second power. So we can place that here. Now with the next term, we have negative 4x and we factor x. So it's like we're dividing by x and we will get negative 4. Now the x squared minus 4 is actually considered to be a difference of squares, and we could factor it even further. So difference of squares, you take the square root of the first term, so that will be x and x, and the square root of the second term, which is 4, it could be positive 2 but also negative 2. And I say negative 2 because negative 2 squared is equal to negative 2 times negative 2, which is equal to 4. So whenever we take the square root of 4, we could have two possible solutions, positive and negative 2. Sometimes we only work with the positive square root. We call that the principal root, but sometimes we work with both. So now that we have factor the polynomial completely, or the equation, I am going to use the zero factor property and that says that each factor could be equal to 0, or one of them, or two, or all of them. So from the first factor, that will be equal to 0. The next one, in fact, yes, all of them are equal to 0, or could be equal to 0, equal to 0. And the third one, x minus 2, equal to 0. So what I'm going to do here is solve for x. So the first one is already done, x equals 0. For the next equation, x will be equal to negative 2. And for the third one, we will have x is equal to positive 2. So from here, you could see that if we were to list x-intercepts, we will take the x values that we found, and we want to list them as points. The y value by default is always 0. So we have 0, 0, negative 2 for x, and then 0 for the y. And then finally we have 2 for the x and 0 for the y. And we could see those x-intercepts being here. Now, since we have one point at the origin, that one is also going to be considered the y-intercept. So any point at the origin is also, it serves two purposes. It's an x-intercept and it's also a y-intercept. Symmetry. Graphs of equations, remember, not functions, only equations, can have three types of symmetry. Well, they could have symmetry with respect to a point too, but let's just focus on symmetry with respect to the x-axis, like the example that we see here. We call this x-axis symmetry. So imagine if you had this was a piece of paper, and then you folded that in half along the x-axis. So you could see clearly that the two curves that you could see here are reflected, or if this was folded, you will have the two curves overlapping on the paper. Or same thing if the x-axis was a mirror, or let's imagine a lake, a body of water. Perhaps the reflection of this curve will be on the water on this side. So that is considered an x-axis symmetry. The next one will be symmetry with respect to the y-axis. So if this was a piece of paper again, and we were to fold it in half along the y-axis, and then we could see that how this side will overlap with this side. Or if this was a mirror that was vertically there, you could see the reflection of one on the other. So the third one, and this is y-axis symmetry. The third one is called the symmetry with respect to the origin. And remember, here is the origin. And what happens here is that the points could be mirrored in that way or reflected. And if you have, let's say, a point like -2, comma, so if we have the point, let's say -2, or no, I want to say, yeah, -2 and -8, and so then the point that will be reflected across the origin, therefore symmetric, it will be the same numbers but with the opposite signs. As you can see, -x turns into +x, -y turns into +y. So the point will be +2, +8. Now when we have the y-axis symmetry, we could see how the y-coordinate remains the same, but the x-coordinate changes. So an example of a point could be 2, 4, and the point reflected across the y-axis is going to have the coordinates -2, 4. So the y value stays the same, and x will have opposite sign. And let's go back up to the one with the x-axis symmetry. So for that one, you could see how the coordinate that will change is the y-coordinate. So I'm going to give you an example of a point. So let's say we have 2, 6. Let's say 2, 3. So then the point that is reflected from there across the x-axis is going to be 2, -3. So here the x remains the same, but the y changes. So for x-axis symmetry, y has the opposite sign. So when we say opposite, we refer from positive to negative, or from negative to positive. So to summarize the 3 basic types of symmetry, we have number 1, a graph is symmetric with respect to the x-axis whenever the point x comma y changes to x comma negative y. So you see how the opposite letter is the one that is changing. For the symmetric, for a graph to be symmetric with respect to the y-axis, the point x comma y is going to switch to negative x comma y. So the opposite letter of y is the one changing. And then finally, for symmetry with respect to the origin, the point xy will change completely to negative x, negative y. So both letters will change. So both x and y changes to its opposite, to their opposite. Opposite signs. Okay, so let's practice the problem on how to check for symmetry. And we could see here a table of values. Remember, to find a table, you are given, and this is actually a good example because we have numbers that are literally on the left and right side on the y-axis. So we have positive numbers right here, 1, 2, and 3, and we have negative numbers for the values assigned to x. So if we were to substitute those x values into this equation, for example, if we say for x equals 1, if x is equal to 1, then the equation, the value for y could be found with x squared minus 2, which will be positive 1 squared minus 2. So that will be 1 minus 2, which will be equal to negative 1. And we could actually see that right here on the point. Negative, put for x equals positive 1, the y value equals negative 1, which will be the point here. Now, if we do the same, but not with x equals negative 1, then we could see how my substitution, as long as I keep my x value inside parentheses, and I do that, so I'm replacing my negative 1 instead of these x here. Remember, that's the same thing we did here, but with positive 1. Now we're doing it with negative 1. And a negative 1 times a negative 1 is going to give me a positive 1. Minus 2 is going to equal to negative 1 again. And so we have that. This looks a little bit weird. I'm going to write it better. There we go, that looks better. So we have that the same y value, and we can see that here. And we could also see that point right here. So you could see that even though the x is changing, the y value remains the same. So for any point that has x comma y, the reflection across the y-axis is going to be negative x comma y, meaning the y value stays the same because it's reflected across the y-axis, but the x value changes to its opposite sign. And that is what you could see here. So you could plot a graph and look at it and determine graphically if there is symmetry or not. In this case, if you were to fold the graph along this line, the y-axis, you will get exactly the same thing on both sides. You could also see how the point 2, 2 is reflected and so it's -2 because the x value is the one that changes to its opposite when we have symmetry across the y-axis, and we could see that here as well. So let me highlight that. Y-axis symmetry. And then, of course, we have the 0.37. So reflected across the y-axis is -3, 7. So that would be the graphical test or numerical test. By looking at the table, you could also determine how these 2 points have the same y value, but the opposite x value. And then you could also determine how for this 2, same thing, the x value is changing, the y value is repeating. And then lastly, for the ones that we have here, the same y value, but the x value is the opposite. So that's the numerical way of determining, and by looking at the table or looking at the set of points that I have here, or by looking at the graph. That will be the graphical way. Now let's go ahead and learn about the algebraic test for symmetry. And so what we're going to do is the same thing that we've been talking about, but instead of analyzing if the x switched from positive to negative or the y or both, we are going to be replacing the variables. So to test for symmetry with respect to the x-axis, we're going to take the positive y and replace it with a negative y. So we're going to change the sign of y to test for symmetry across the x-axis. So it makes sense that if we're testing for some symmetry across the y-axis, we are going to change x to its opposite sign. So we will be replacing positive x with negative x. Now, what are we trying to accomplish? Well, we're trying to check if the symmetry is true, and if it is true, we will get an equivalent equation after doing that, equivalent to the original before we replace the y with negative y or the x with negative x. And then finally, we have the symmetry across the origin. And so that will be by replacing both x with negative x and y with negative y. So we change x with negative x and y with negative y. So after doing those changes and simplifying it, simplifying the equation, if we get something that is equivalent to the original, then yes, we could say there's symmetry with respect to the origin. So those are the steps to find symmetry algebraically. So we're going to test for symmetry on the same equation that we used to look at the table and the graph, but we're going to use that to test algebraically. So it is x squared minus 2. So first I'm going to write here y is equal to x squared minus 2. And so for the first type of test, we're testing for symmetry across the x-axis. So we're going to change the y to, instead of positive y, we're going to change it to negative y. And we will get x squared minus 2 on the right side. Now, since we are trying to make it look like the one on top, like this one, then we want the y to be not negative but positive. So that's going to require for us to multiply both sides by -1. So if we do that, we will do that to both sides, the left side and the right side. So I am using parentheses because the -1 needs to be distributed to the whole expression on the right side. So -1 times negative y is going to be positive y. And negative 1 times x squared is going to be negative x squared. And then negative 1 times negative 2 is going to be positive 2. So now if we compare the equation that we got after substituting y with negative y, if we compare it to our original, we could see clearly that they are not the same. So we say that there is no symmetry with respect to the x-axis. Now let's try to test for symmetry with respect to the y-axis. So to do that, we need to change the x with negative x. So in this case, this letter x is going to be replaced with a negative x. I don't know why I put negative 2, negative x, and then we have this square and minus 2. And remember, I told you if you are substituting a negative number or a negative quantity, just make sure you use parentheses. So if I simplify this, I will get negative x times negative x, which will be positive x to the power 2, and then minus 2. Now, if I check that equation to the original equation, they are identical. So we could say that the equation has y-axis symmetry. Now finally, to check for symmetry with respect to the origin, we will have to take the original equation, and I'm just going to rewrite it here. And now I'm going to replace both the x and the y with negative variables. So negative y, and then we have negative x to the power 2. And I don't know why I keep doing that. Minus 2. So here we will have negative y is equal to x squared minus 2. So then if we multiply by negative 1, and after multiplying both sides by negative 1, because we want the y to be positive, remember we're trying to compare it to the original equation. So negative 1 times negative y will be positive y. But then when we distribute the negative 1 here, we will get negative x squared with the negative outside, which is very different than the one we had here. And then negative 1 times negative 2 will be positive 2. So clearly that new equation is not identical to the original equation. So then this has no symmetry with respect to the origin. No origin symmetry. And the one here has no symmetry with respect to the x-axis. So the only one that we found was with respect to the y-axis. Now, some equations may have symmetry with respect to the x-axis, others with respect to the origin, others with respect to the y-axis, and others might just not be symmetric at all, which is the case of the next example that we're going to be looking at. And so if we consider the equation, and I'm just going to go ahead and test it for symmetry here. So if I test for symmetry across the y-axis, I will have to change my x to negative. And so at that point, you could check, let's say, y-axis symmetry test. You could see clearly that that is not the same as the original equation. So we say no y-axis symmetry. If I want to test for symmetry with respect to the x-axis, I will make the y negative. from the original equation. And so here, by multiplying each side by -1, I will get positive y. But remember, we also need to multiply the other side. And so that will just simply remain as a negative sign in front of the absolute value quantity. And so it's not just that they're not the same when we compare them, but they are the complete opposite, because here's negative and the original has a positive in front of the outside of the absolute value in front of it. And so if I go ahead and test for symmetry with respect to the origin, it's pretty obvious we will not get it either. So we're gonna go ahead and graph it. Now, how were the points found? So for that, I'm gonna do some of the work here. So for example, if we have x column is -2, and the equation that we have is y equals to the absolute value of x minus 1. So absolute value is considered to be within the parentheses group. So brackets, braces, parentheses, absolute value, fraction, bars, they are considered into the grouping symbols. That's what they're called. So within the order of operations, they are the first ones that we have to compute. So after we substitute the x value here, such as -2 minus 1, we will perform the operation inside the absolute value first, and that will give us the absolute value of -3, which it happens to be +3. And so that is how the 3 is found. Now, if we substitute, let's do the next one, -1. So y is equal to the absolute value of -1. Now, what we're substituting is the x inside the absolute value. So I'm getting my x values from here, and I'm just simply choosing those, the same ones, but this is also a continuous function where the domain, the values that the x could take, they are from -infinity to +infinity, so it is any real number. So -1 minus 1, that will give me equal to -2 inside the absolute value. Then we take the absolute value, and that will be +2. Once you take the absolute value of a number, whether it's positive or negative, your answer is always positive, because the absolute value is measuring the distance from that number to 0. And so distance is always positive. Now, if we substitute x with a 0, we will get y is equal to the absolute value of 0 minus 1. And so this will turn into the absolute value of -1, which is 1. Now, the next one is 1 for x. So y will be equal to 1 minus 1, and that will be 0. So I'm going to do one more. If x is 2, we will have y is equal to the absolute value of 2 minus 1, absolute value. And so this will be 2 minus 1 is 1, positive, inside the absolute value. So if the number inside the absolute value is already positive, once you take the absolute value of it, the answer will remain positive. Okay, so now if we plot the points on the graph that we have here, we will have -2, 3. So here. The next one is -1, 2. We have 0, 1. We have 1, 0. We have 2, 1. We have 3, 2. and we have 4, 3. So I am going to connect the points because I know it's the absolute value function and it is continuous, meaning that the x values don't have to be only integers. They could be fractions and they could be decimals. So it is connected. And I'm also going to go ahead and extend it a little bit and just do like some arrows at the end just to indicate that the graph keeps going. It's not just that little portion that goes from x negative 2, like it was given to us, to x positive 4. It just keeps going. The domain, it is all real numbers. So there we have it, the sketch of the graph. Now let's move on to our next slide. And now we're going to go ahead and work with the equation of the circle. And so the way we're going to derive the equation of the circle, and the equation in standard form, because we also have the general form. So this is called the standard form of the equation of a circle, is going to be here. And you will definitely have a question like that on your first exam. So please don't forget about it. It is one of the formulas that you're supposed to study. So let's consider the formula that we were using for the distance between 2 points. And so that was the square root of x sub 2 minus x sub 1, and then we square that, plus y sub 2 minus, I'm going to make more space, y sub 1 square, and that is equal to d. So if we consider in this case that our x sub 1 and y sub 1 is going to be given by the center of the circle, and then the x sub 2 and the y sub 2 are going to be any point on the circle, like that one. So we don't know what the values are for that point, so we're just going to call them xy. Okay, that's going to be replacing x sub 2 and y sub 2. So we have x and y. And then just for convenience, we decided to label the center hk, but also we're using it as our x sub 1. So h is x sub 1, the x coordinate of the center, and k is y sub 1, or the y coordinate of the center. Now, what we're trying to find here is the distance between the 2 points. So instead of calling it d for distance, we're going to call it r for radius, because we know that the radius is that segment that goes from the center to any point of the circle, and in fact is constant. So any point that satisfies the equation of the circle that we have highlighted down here, that is gonna form the circle, the accumulation of those points. So if we have that equation and then we decide to square both sides, we will simply get rid of the square root on the left side. So we will have x minus h square plus y minus k square, and then we will have r squared right here. So based on that, we are going to go ahead and find how to write the equation of the circle, and then we will be graphing a circle. So we have here example 8. We have a point that is on a circle, and the point is 3, 4. Let's go ahead and graph it. And the center, that is just some random point, the center happens to be at -1, 2. So there. And so we're going to write the standard form of the equation of the circle. So if we start with that equation, or we could just go ahead and get rid of that, make this r squared. So we will square both sides. So here we have r squared, and here we will just have x minus h squared plus y minus k square. That would be the standard form of the equation of a circle. So to find the radius, we're going to use that distance formula. In fact, it will be the formula that we had here. R is equal to the square root of, I'm going to just go ahead and get rid of the square here. So the center of the circle, that will always be representing h comma k. So we have that is -1 comma 2. So we will be substituting those numbers into here, h and k. And then of course the point that we have here, that is giving us an x and a y. So we will be substituting those. And we're doing that only to find the radius, okay? To find the equation of the circle, we will actually just leave x and y where they are. Because to have that type of equation, we need to have two variables, x and y. So actually, let's do that first. So if I substitute the value of h, which is -1, that will be here in parentheses. And the value for k, which is +2, will be here. So what will happen is that here we have a double negative, so that will turn into +1. And then here we have y minus 2 square. Now we still have to find the radius, and that's why we're using the distance formula. So if we substitute x with 3, and then h with the -1, and then we have to square that, and then we have a plus, so we substitute y from here, that's a 4, and then we have a minus k, which is a 2, and then we have to square that. So we're going to get the square root of, here we have this double negative, so that's going to be 3 plus 1 square plus, we could go ahead and subtract that. 4 minus 2 is a +2, and then square outside. So this will be r is equal to 4, the square root of 4 square plus 2 square. So inside the radical, we have 4 square, which is 16. We have 2 square, which is 4, and that will give me the square root of 20. Now, to enter the answer of, if the question is, what is r equal to? WebAssign might not take the square root of 20 because this could be simplified a little bit. So the square root of 20 could be factored as the square root of 4 times 5. And so from here, you could take the square root of 4 and multiply it times the square root of 5. So we could take the square root of 4, and that would be a 2, because it is a perfect square, and then the square root of 5 will just stay inside the square root of 5, like that. That would be the answer for the radius. Unless they want a decimal approximation, then go ahead. However, to write the equation here, it's going to be r squared. So I could just leave it as the square root of 20 because then I'm going to square it. So if I square the square root of 20, it's just going to give me 20. And that is only because for the equation this in standard form, you need the radius square. But if you need just the radius, then the square root of 20 might not be accepted by WebAssign. So that is the circle, and we have the center here. We found the radius, that is the length right here, distance formula. And so if we were to trace that circle, actually I'm going to try that. Oh, there we go. Kind of, not exactly, but it will be something like that. So finally, we have the application, and for this example 9, we're going to go over 3 types, the 3 common approaches. We have the numerical approach, so we're going to be constructing a table. We're going to use the graphical approach, so we're going to draw and use the graph. And then finally, we will use the algebraic approach, so we will be substituting and then using the rules of algebra to simplify it. So let's get started. That would be the last problem for the section. So we have here the median recommended weight, and that will be y. And I want to clarify, this is the output. We will continue using these words. In pounds for men of medium frame who are 25 to 59 years old can be approximated by the mathematical model, and we have the equation here. Now, since this one is for men who are 25 to 59 years old, and actually no, that will not be our independent variable. Our independent variable is actually the height. So it's actually here. I should have just continued reading. So where x is the men's height. So the h here is not really that relevant. I guess we're just trying to restrict that age to the time where. So the first task is to construct a table of values, and we are gonna find the table. I know the table is already there, but I want to show you a way that you could find a table so that you can help yourself when you're doing the homework. So one of those, of course, will be to enter it on a calculator. Now, since I haven't really show you how to download your calculator, I know not all of you have one. You cannot rent one from the college at this time. I'm going to go ahead and show you how you will graph this on Desmos and how you will find the graph for that. So we're going to open a browser, and we're going to go ahead and type in desmos.com, press enter, and we're going to go ahead and go to graphing calculator. Then on this side, on the left side, we're going to type in the equation, and I'm going to type it exactly like it was on the slide. So it will be y equals, and then we're going to have 0.073 x square. So that's a little tricky here. No. Okay, let's see if I can find that symbol. Interesting. Okay, so I cannot find it. Looking for the caret symbol, which I really don't know why it isn't here. Okay, so I found a different way to enter it. So now I'm using my regular keyboard. So that's the symbol for square. I press Control or Shift number 6. That's the caret symbol. And then we put a square there. It's a smaller number, so now I'm going to press the right side arrow to get out of there. And then I'm going to keep entering the expression. So now we have minus 6.99x. And then finally, we are going to have a plus 289, and we press enter. Now, I don't know why I cannot see the graph, so I'm going to go ahead and make this bigger so you could see. Okay, so as you can see, the graph is not visible to us here. So what I'm going to do is zoom out and see if I can find it. Oh, and it's right there. So now I can, with the mouse, I can hold on to the left button and I can move the graph around. I can also zoom in so that I can get a better picture from it. Now, if you recall, the function equation, and I'll show it to you, it's for men whose height is from 62 to 76 inches. And so what this means is that at 62, that is like 5 feet 2 inches. And then at 76 inches, that will be like 6 feet and 4 inches. So that is gonna be restricting the way we look at our x values. So let's go back to the graph, and we are going to say here in the settings, I'm gonna change my x values. Remember, those are the height in inches. And so I want those to go from 62 to 76. And so now we can see a better picture of the graph. Now for the y values, we're talking about weight. So we could see that we don't really care about negative weight. We want positive weight. And so it will be something like that. So we have here 100 pounds, 200, and so on. I can close that as well. And so the questions are construct a table and find what it will be at 62 inches of height. And so you could see here the number 62 is located here. So if we follow that, I mean, we don't have a table, but this is a very nice feature from Desmos that we could trace a point right there. So at 62 inches, the height is, at 62 inches for height, the weight is 136 pounds and some change. Now the next question is, what about 64 inches? So here's 64. If we trace the graph, right there, it will be 140 pounds, 0.648. So depending on how WebAssign wants you to round, that's how you will enter your answer. And the same thing can happen. We could go all the way to 76 inches. And If we trace the graph right there, oops, we get 179.408 for the pounds. So that is a way to do it. And I believe you could get a table from here, but I am not so sure how to find it. But that's why you should get your graphing calculator. So actually, I just found how to get the table. So let me show you. So the same place where you enter the equation, you're going to press the settings, or it says edit list. And I believe it could be here, convert to a table. And so if you have a table, you could scroll down to find those x values that we needed. Or I believe you can enter them. So let's try that. If we enter 62, we get the result for the weight. The other one was 64. Then we had 66, 68, 70, 72, 74, and 76. And so the numbers that you could see here on the right side, those are the answers to part A. Now, if we are just approximating with the graph that we were given on this part right here, which is part B, use the table of values to sketch the graph and then approximate. So what will be the weight for a man whose height is 71 inches? So 71 will be located right here in between 70 and 72. So it's that dash pink line. And so if we approximate, it looks like it could be 160. But if we actually substitute, which I'm just going to do it with decimals and enter here instead of -1, I'm going to put positive 71, press enter, and I get the result. So you can see here it will be 160.703. I forgot what it was. 160.703. Okay, and so that is the end of the video.